Hey guys, welcome back to Eureka, and in this video we're going to be doing the continuation of the periodic sheet for pure math, okay? So activity 2, number 1, page 29. Here we go. So they're telling you use the binomial theorem to expand this up until x cubed, right? So until we get x cubed, so k equals 3. Now we know that we can rewrite this as x plus 2 multiplied by 2 minus x raised to the power of minus 2. And of course, the binomial theorem tells us that k goes from 0 to infinity, and combination k, big X is raised to the power of k, and this would be the expansion of 1 plus big X raised to the power of n. Right? So, yeah. In this case, we need a 1. And how are we going to get a 1? Well, we can factor out a 2, and I'm going to show you how we're going to factor out a 2. And you guys should really pay attention at this point. So let's factor out the 2. So we're going to get x plus 2 multiplied by 2 to the power of minus 2, because there's an exponent. And we're going to get 1 minus x squared to the power of minus 2. Alright? And now it's simple mathematics. We're going to omit this from the binomial expansion. And we're going to use the binomial expansion to solve for 1 minus x squared. Right? So k goes from 0 to infinity. Nk minus x over 2 raised to the power of k, right? So let's start when k is 0. And let me get more space. When k is 0, we're going to go like this. So we're going to get minus 2, 0. And k is just minus x over 2. So that's raised to the power of 0 plus minus 2, 1. Minus x over 2 raised to the power of 1 plus minus 2, 2. Minus x over 2 raised to the power of 2 plus minus 2, 3 minus x over 2 raised to the power of 3, right? So let's use a calculator to evaluate this. So give me a very small amount of time. To evaluate this, we're going to get 1 plus x plus 3 over 4 x squared plus 1 over 2 x cubed, right? And of course, we're gonna add these back. So yeah, multiplied by 2 raised to the power of minus 2 multiplied by x plus 2, I believe. Yeah. So now let's just simplify all of this. Let's simplify. We're gonna get 1 over 2 plus 3 over 4x plus 5 over 8x squared plus 7 over 16x cubed. And there we go. That is your answer for part, let's call it part A, but it's actually number 1. So let's go. 2a. Given 1 minus 4x raised to the power of 1 over 4, expand it until we get x cubed, right? So here we go. Let's expand it until x cubed. Using the binomial theorem, it's going to be 1 over 4, 0. Minus 4x raised to the power of 0 plus 1 over 4, 1. Of course, we didn't need to factor out anything because this is a 1. Yeah. Plus 1 over 4, 2. Minus 4x raised to the second power. And 1 over 4, 3. Minus 4x all cubed. Now, we're going to use a calculator to evaluate this. So here we go. Let's start. So, yeah. We're going to get 1 minus x minus 3 over 2 x squared minus 7 over 2 x cubed. This is equal to this using a calculator. So that's part A done. Part B. They're telling you show that 8 to the power of 1 over 4 is equal to 2 multiplied by half raised to the power of 1 over 4. And then substitute x to be equal to 1 over 8 to evaluate the 8 to the power of 1 over 4. So let's do the first part of the question. So yeah. The first part of the question says, guys, I'm really having some weird difficulties here. Yeah, so we need to prove this. Well, let's just prove it. This is just equal to 2 over the cube root of 2 the fourth root of 2, which is just 2 to the power of 1 minus, let's see, 1 minus 1 over 4, which is just 2 to the power of 3 over 4. Now 2 to the power of 3 over 4 is the same thing as saying 2 cubed, the fourth root of 2 cubed, and 2 cubed is just 8, right? So this is equal to 8 to the power of 1 over 4, and 8 to the power of 1 over 4 is just the cube root of 8, the fourth root of 8. So these two are equal. Now in this formula, let me just scroll up a bit. In this formula, we can find 1 over 2 raised to the power of 1 over 4, right? X is 1, let x be 1 over 8. It's going to be 1 minus 4 over 8, which is just half raised to the power of 1 over 4. But we're trying to find 8 to the power of 1 over 4. So we need to multiply by 2, right? So let's just take this expansion downwards. So let me rewrite it. 1 minus x minus 3 over 2x squared minus, and just go up, 7 over 2x cubed. Now if x equals to 1 over 8 and we multiply this by 2, we will get 8 to the power of 1 over 4. Very close to 8 to the power of 1 over 4 actually. So all we have to do is just substitute. It's going to be 1 minus 1 over 8 minus, let's see, 3 over 2 multiplied by 8 squared minus 7 over 2 multiplied by 8 cubed. And using a calculator, you should get like 1.6895. And then it goes on. Right, so let's go to part C. They're telling you use a calculator to find 8 to the power of 1 over 4. This is quite sad. So we actually need a calculator to do number C. And they're telling you just evaluate it. So let's evaluate it. So yes. 4, yeah. And then they're telling you subtract it from our answer. We want to find the percentage. So we need to subtract it from our answer. And we get somewhere about, 0.5. Yeah. Just give me a second here. 1.68. We get around 0.5, and then to change it into a percent, we just multiply by 100, right? So yeah. I skipped way too many steps, so let me show you. They're telling you find the percentage. Now how do we find the percentage? Well, we evaluate this using a calculator. We subtract when we evaluate it by hand. By hand just means using the binomial theorem. Yeah. Over what we assume to be correct, which is just the calculator method, and to turn it into a percent, we multiply by 100. And that should be your answer. This is by calculator. This is what we evaluated, like over here. You just, divide by the calculator method. Now, let's go to number 3. Number 3 tells you expand 1 minus 3x raised to the power of 1 over 3 until you reach x cubed. So yeah, let's do it. 1 minus 3x raised to the power of 1 over 3 until you reach x cubed, right? So here we go. 1 over 3 from 0, 1 over 3 from 1, 1 over 3 from 2, 1 over 3 from 3, right? Minus 3x raised to the power of 0, minus 3x raised to the power of 1, minus 3x raised to the power of 2, minus 3x raised to the power of 3, and we need to sum them up, right? So yeah, let's use a calculator to find this, and we're gonna get something. So yeah, we're gonna get 1 minus x squared minus 5 over 3x cubed. All right, that's part A. Now let's look at part B. Part B, they're telling you substitute 10 to the power of negative 3 to find the cube root of 997. So let's just substitute 10 to the power of negative 3 squared minus 5 over 3 multiplied by 10 to the negative 3 cubed. Now you can evaluate this using a calculator. You're gonna give it a second here, it's calculating 9.9899, and I quote, okay, and I quote, this is the answer. Alright, so now let's move on to activity 3. Alrighty, give me a second here, let me just flip the page and let me get a new page. So here we go. let's just close this or open this. So, yeah. Activity 3. Number 1, they're telling you use the binomial theorem to expand 1 minus x all inside the square root, right? So we can rewrite this as 1 minus x raised to the power of half. And of course, using the binomial theorem, it's going to be, this is just a stupid question. It's going to be half minus x raised to the power of 0 plus half 1 minus x raised to the power of 1 plus half 2 minus x raised to the power of 2 plus half 3 minus x raised to the power of 3. Again, let's use a calculator to evaluate this. We're going to get 1 minus half x minus 1 over 8 x squared minus 1 over 16 x cubed. Right? And this is a pretty easy example, pretty easy activity. Now let's go to the next question, which is, if I'm going way too fast, then bear with it. We don't really have time. The periodic's tomorrow. They're telling you determine the first 4 terms of the expansion 1 over the square root of 2 plus 5x squared, and then state the values of x for which this is equal to its expansion. So let's just solve the first part of the question. Right, so this can be rewritten as 2 plus 5x raised to the power of minus half. And of course, we can evaluate 2 to the power of minus half. Righty? X squared in the question. X squared. Right? Power of minus half. We can evaluate this using the binomial theorem. It's going to be equal to, and again, if you read the question, they're telling you evaluate it up until the 4th term. So when n equals 3. So it's going to be minus half from 0, minus half from 1, minus half from 2, minus half from 3. And of course we have 5 over 2 x squared raised to the 0 plus 5 over 2 x squared raised to the 1 plus 5 over 2 x squared raised to the 3 plus raised to the 2 plus 5 over 2 x squared raised to the 3. Now, of course, we're going to use a calculator to evaluate this. And of course, don't forget the constant, which is 2 to the power of minus half, right? So using a calculator, this will give you 1 minus 5 over 4x squared. Sorry, not x squared, 2 squared. 75 over 32 x to the power of 4 minus 625 over 128 x to the power of 6, and we have 2 to the minus 2 here, to the minus half here. So yeah, you can evaluate this, but I'm just going to keep it like this. And then they're telling you find the values of x for which this expansion works. So yeah, in order for us to find that, we're actually going to go to the first part of the question. Sorry. Yeah, which is 2 plus 5x squared. Oh, whoa. 2 plus 5x squared raised to the power of minus half, right? We rewrote this as this. Raised to the power of minus half, right? We know that in order for this to work, sorry about that. Whoa, in order for this to work, big X must be, so the absolute value of big X must be less than 1 in order for this expansion to work. Like, in order for this expansion to work, n from k, x raised to the n, x, big X actually, must be less than 1, the absolute value. So this will be 1 plus x raised to the power of n, right? This is the condition, and it's in the book. So let's evaluate this. So we're going to get 1 and minus 1. That's the definition of absolute value. The distance from x, that's the definition. And let's multiply by 2 over 5 on both sides. Yeah, and well, let's take the square root of both sides. So the square root, of course, we can't have a negative number. So yeah. Negative is outside. So that's number 2 done. Let's move on to number 3. Give me a second here. So I'm gonna show you number 3. So here we go. Number 3 tells you in A, they're telling you determine the first 3 terms of the expansion of 1 over the square root of 4 plus x squared, and then state the values of x. So basically restrict the domain as we just did, like the absolute value. So yeah, let's do part A. Part A is just 1 over the square root of 4 plus x squared. They want us to expand it to the 3 terms, to the first 3 terms. So we stop when k equals 3. Let's rewrite this. Let's factor out a 4 to the negative half. And let's evaluate this. They said the first 3 terms, so here's the evaluation. Of course, don't forget the constant, so it's going to be negative half from 0, x squared over 4, 0, plus negative half 1, x squared over 4, 1, plus negative half 2, x squared over 4 to the 2. Right? Now let's evaluate this. We're gonna get, using a calculator, very dyslexic today, very dyslexic. Now 4 to the power of minus half is just 1 over 2. And then let's just evaluate. We're gonna get, so yeah, I'm just gonna remove the half and I'm gonna multiply it inside the brackets. We're gonna get half minus x squared over 16 plus 3x to the power of 4 over 256. Alrighty, so I'm gonna stop here for a second because we're done. So yeah. Okay, let's continue. Let me close the brackets. So yeah, this is the first part of part A is done. Now let's look at the second part. It tells you state the values of x. So let's state the values of x. So we look here. We know that x squared over 4 must be less, like the absolute value must be less than 1, right? So yeah, we can say that x squared over 4 is less than 1 and is between 1 and negative 1. Let's multiply. Now, by this definition, negative radical 2x radical 2. Now, you might be asking, why didn't we put the negative under the radical? Well, I'm not going to tell you why, because to be honest, you don't need to know why. Just remove the negative, and let's continue. These are this is the domain of x. It's between. Sorry, why did I put a square root? I'm an idiot. Yeah, so the square root of 4 is just 2. So x is between 2 and negative 2. Let's go to B. They're telling you use the expression obtained to evaluate the square root of 1 over 5, right? So the square root of 1 over 5, what must x be? So remember the first part of the question said that it's going to be 4 plus x squared over 1 square root. Well, x here must be 1 in order for us to get a 5, right? So let's just substitute a 1 into this equation. Let me rewrite it. So half minus x squared over 16 plus 3x to the power of 4 over 256. We said that x must be 1, so let's just plug in a 1. And you can use a calculator to evaluate this. You get something around 0.4492. That's part B done. Now let's do part C. Part C tells you find the calculator value of the square root of 1 over 5, and then find the difference between the two answers. So using a calculator, the answer is 0. Blah blah blah. Use a calculator, and then you find the difference. The difference is somewhere about. I got the difference to be very, very, very small actually. Let me just, yeah. Do it on the calculator again. So the difference I got was 0.0020, and that is the answer. And we're done. Thank you guys for watching, and as always, easy.